our children when I was little. I was like, I want to have milk out of and cool it in the stream. I loved it. Okay. All right. So here's my plan for the lesson. I want you to have your notes out on the side, and I'm going to go through each one with you real slowly so that you can get used to how the steps break down. The first step in the first arrow, what did we write in that first arrow yesterday? Find the LCD, the least common denominator, okay? And what's the very first part of that process? What is factor each denominator, okay? Now, what's up with this first problem? Yeah, nothing needs to be factored, and there's not a denominator on the -2, but we know it's what? 1. 1. So you look at each of the denominators and see if you can factor them. In this case, they can't be factored, and that's okay. Right? Not everything needs to be factored all the time. So then what does part B say? Someone read it to us. Yes. Build the LCD by using each of those factors one time. So remember, the point is to get everything with the same denominator because they're fractions, right? And that's how you add and subtract fractions. You find common denominators. So the LCD here is built from each of the denominators. So this first one has an R, so our common denominator needs an R. It has to be represented. The second fraction has a 1, so ours needs a 1. And the last fraction has an R. Why am I not going to write that again? Because we already have an R. The only time you need to repeat stuff is if it's repeated in one of the denominators. Like if this had 2 R's, we would need 2 R's, one for each. But otherwise, don't repeat stuff because it's going to make your math too complicated. And technically, did we even have to put a 1? Not really. But for this problem, I'm going to keep the 1 all the way through just to be like particular. And then I'm going to not do it later if we have it later. So there's our LCD, right? Okay. What does the next arrow say? Rewrite the fractions. Well, how do we start doing that? What does the main step under the arrow say? Yeah, by the missing LCD factors. So you go to each fraction individually. So we've got 8 over R on the first one. Which factor from the LCD is this one missing? The 1. So you multiply top and bottom by 1, by whatever it's missing. Okay. And then equals, and then you go to the next fraction, the -2 over 1. What's its denominator missing? The R. So multiply the top and bottom by R. And then on the last fraction, what is that denominator missing? The 1. So you do the top and bottom by 1. Right? So that's all from the rewrite fractions. What does the next arrow say? Clear the denominators, okay? So it says part A, remove them. This is very satisfying. I'm just going to cross them out. They're gone. And then it says to distribute, okay, or multiply in the numerators. So we've got 1 times 8 here, which is 8. -2 times R is -2R. And then plus 2 times 1 here is just 2. And now we have this much easier equation to work with than the beginning problem, right, with the fraction form. So that's the point of finding common denominators and rewriting, because then you can just drop the denominators off and do this thing. So what would we do next here? What's the next step? Solve, right? The next arrow, solve, and we would do that by subtracting 2. Go ahead. So that gives me 6 equals -2R. Divide by -2. R equals -3. Maybe. Why am I saying maybe? The EVs. We have to check for excluded values. Okay, that's the very last step. Extraneous solutions. So that was our lesson from last Friday where if a denominator has a variable in it, you have to set it equal to 0 and solve. That's from last week, okay? Again, Go get your education. How are you in the hallway again? That girl who's always in the hallway. Which one? Um, excluded values. And so up here with the denominators, the only one with a variable in it that happens to be the same, so we only have to do this one time, is the r. So for excluded values, we set it equal to 0 and solve, but there's no solving that has to be done. It's already just r. Right? So r cannot equal 0. Did our solution equal 0? No, so it's good to go. On your quiz, in case you might forget to do the excluded values, I'll have a thing on there, like a prompt, like excluded values with a line to make sure you remember to do that. Okay. Yeah, it would be incorrect if you don't do it. So I'll be sure to like ask you to prompt you for it. All right. So that was kind of a like sort of easy one, right, to warm us up. We didn't have to factor any denominators, but on number 2, we do have to. Which thing, I'm sorry, number 3, going to the right. Which denominator can be factored over there on number 3? The 5r plus 30. Its greatest common factor, that's right. So I'm just going to rewrite this as 5 times r plus 6. If you don't factor there and you try to go build your LCD and you were to just use the 5r plus 30, it's going to make your problem really ugly and hard to work through. So that's the benefit of factoring and not forgetting to factor. It'll make your stuff simpler. All right, so we factored. That was the first part of LCD. The second part B, it says build your LCD by using each of the factors from your first step one time. So here we go. This is your common denominator. What needs to be represented from here? Like, tell me what to write down, I guess is what I'm saying. The r plus 6 and the 5, okay. The second denominator needs what? R plus 6? Do I have, all right, not, you're skipping one. I'm still building the common, the group one. But yes, we'll do that in just a second. So the second denominator already is an r plus 6, and I already have that, so I'm not going to write it again. Okay. And then a 1, right? But for this problem, I'm not going to do the 1. We did it over there, but we're going to kind of not do it now and see how you feel about that, okay? You can if you want to, but it's not technically necessary to keep that 1 every time. But if you like it, because it like keeps it. And this one with the 1 in the bottom, oh yeah, I had just said we're going to have to write the 1. Okay, all right. So then the next step is to rewrite the fraction. So we're going to multiply each fraction by whatever its denominator is missing. What's missing in the first fraction? Nothing. So we're going to keep it the same. And I'm going to still use the factored form instead of the original form. And then what's the second fraction missing? 5, okay? So multiply the top and bottom by 5. And what's the last one missing? Everything. Everything. So we're going to multiply the top and bottom by the whole LCD. So the red is the stuff that was missing. And now what we going to do? Right, cancel out all the denominators. And when you go to your next step, go ahead and do all the multiplications. It will save you some writing. So the first one, I actually don't have to multiply anything. I just have r plus 10, good. Right, plus 5r plus 30 times that 1, which doesn't change anything. Okay, and this is a much nicer equation to solve. But the kind of, sort of. I mean, yes, but it doesn't change anything. So now I have, though, variables on both sides and numbers on both sides. So that's a two-step equation. Do you want to get the r's on the left or the right? The left, okay. So if we're moving it to the left, we do minus 5r to both sides. And if you're moving r's to the left, the numbers have to be moved to the right, the constants. So I would subtract 10 to both sides to get the 10 over here. So the 10s cancel on the left, leaving me negative 4r. The r's cancel on the right, leaving me 20. And what's my last step? Divide. That's okay. So r equals negative 5. Perhaps. Okay, because we want to check for excluded values. So here's my excluded value work. When you're setting up and you're putting the denominators equal to 0, you only have to do ones with the variables. So for example, this 5, that's a factor. For excluded values, it doesn't mean anything. It's not going to, there's no excluded value for 5 because it will always be 5. It can never accidentally be 0. The only thing that might ever equal 0 is stuff with a variable in it. So that's the factor that you want to set equal to 0. So r cannot be negative 6. Was r negative 6? No, so we're good. So there's my solution, and there's my excluded value. And I'm going to work through 4 with you, and then give you a few minutes to finish out number 2. And then you'll turn this in with everything copied down, and it'll be a daily grade. The reason why I want to be sure to work 4 with you is because it's a little bit different. It's got AC method, right? Before I scroll up, does anybody need that work anymore? Okay. Your first step is to factor all the denominators. The only one that needs to be factored is which one? Fraction 1, 2, or 3? 2. And which method is that? That's AC. Is it short AC or long AC? Short. So we don't have to do grouping, so it's going to go kind of fast. So we need to know what multiplies to 1 times 10 and adds to negative 7. What say you? Negative 5, negative 2. So I'm just going to cross this out and put that. R minus 5, R minus 2. And then we begin building our LCD. The first fraction has the r minus 2, so that has to be part of my common denominator, part of the group denominator. That's from the first fraction. What do I need to add from the second fraction? R minus 5. It also needs r minus 2, but I already have it, so that's good. And what does the third fraction need? Well, for the group denominator, it needs the r minus 2, but I already have it, right? But yes, now when I go to rewrite, I will have to throw in the r minus 5. So that's just my group denominator. So now I rewrite everything with common denominators. I mean, we really should have chosen shorter words than numerator and denominator. So the first one needs r minus 5, top and bottom. What does the second one need? Nothing, right? It's already got everything it needs. It's complete. So don't change it at all. What does the third fraction need? R minus 5. What's next? Cancel out, right? Drop the denominator. And now, before you rewrite to the next step, go ahead and do any multiplication that you have. Like I have r minus 5 times 1. That doesn't change anything, so it's just r minus 5. And then plus 1, because nothing was changed there. And then I do have, this is a distributive property, so 6r minus 30. And there's some like terms. Where is it? The -5 and the +1. Good. So that's r minus 4 equals 6r minus 30. R's on both sides, numbers on both sides. I'm going to subtract r from the left to move it over to the right. So if I move the r's to the right, I need to move the -30 to the left by adding it. So that gives me 26 equals 5r. Divide by 5. You can't simplify that fraction. So it's 26/5, maybe. Let's check on our excluded value situation. When we factored originally, each denominator has these two factors or some combination. So these are the only things we need to check. Set them both equal to 0, solve. R cannot equal 5 or 2. Did it? No, so it's good. So there's my excluded values and my actual value. I'm not going to work through number 3 with you, but I am going to put the work on the board quietly so that I don't distract you from trying it yourself. So if you haven't tried it, go ahead and take a moment and do that. Look up at my work when you're ready to see how you did. And as soon as you're done, you can turn it in. So if you already feel good about it, you're welcome to turn it in. But if you need time to work it, go ahead and do that now.